Bonjour. This will be another spreadsheet project using Microsoft Excel. Today we're going to play around with some weather data. We did one similar to this in ITECH 100, but this one's going to use some more sophisticated, or rather it'll be a little bit more on your own. Oh yeah, I'm sorry. The link will be broken if you try to do this before I have this fixed. I have this server running locally on my computer. It'll be fine. By the time you see this, this will all be corrected and the video will be posted in here. So there's lots of places where you can get data to use, to analyze, to play with, to explore, to analyze, and there's a lot of debate about what that data is allowed to be used for. What is it okay to collect? What ways is it okay to use it? Especially when you come to like really sensitive stuff like medical data, educational data, things like that. Those are all very, very complicated, and there are actually regulations in place for what kinds of data you can use. So what we're going to be doing is using a little bit less controversial data. We're just going to use a year's worth of weather data that we collect on campus. Here's the server. If you click on the link here in the project, it'll bring you to our Rainwise page. The weather station is on campus. It's kind of over between the two buildings out in the field behind Oak Hall. You can see it. It's on a big pole. There's a thing sticking up in it. And it catalogs all this data. It tells you exactly what's going on, how much precipitation there is. This isn't correct. It snowed a bunch last night, although it hasn't been... No, it's in fact snowing right now. Maybe it only logs rain. I don't know. You can actually download this data using this tool right here. You can go through and say which data you want. You can say, with our account, we actually have a pro account, which we pay for, which allows you to change the interval. The default interval, I believe, is something like 1 hour. But we can actually download data up to a minute interval. And I don't know if that's what... Here, I'll download the start file to my computer. Save. Now the start file is a CSV file, so when we open it, and it should open right away into Excel. It should be, by default, it'll go into Excel. Here it is. Let's see, is this minute? This is hourly data for the whole year, I believe. So 24 data entries per day. Let's see, it's February. Let's see. It is January 2019 through, I believe, February 2020. So it's like 14 months of data. So you'll see that there's actually quite a bit of it here. This is actually one of the ways where Excel is going to vastly outperform other spreadsheet apps like Google Sheets, because Google Sheets is limited in the resources that you have available to you, whereas Excel will utilize your full system's resources. So, so this is actually going to work a lot better on your computers than when we did this project in Sheets. So, go to the Backstage view, hit Save As. Want to find a... Browse. I want to go to my ITECH 1. Let's go to my Google Drive. I'm just going to stick it in there for a place to put it. Now, here's the thing that you really want to change, is you want to make sure that the file type is an Excel workbook. So it'll be CSV by default. We want an Excel workbook. You can do all the edits and stuff that you need to do in this project using it as a CSV, but the second you hit save, all that will be gone. So we'll save it. So now what we have here is a lot of data from our this is all data from our weather station on campus. And let's go through it. Let's see what all the fields are. I'm going to just move this over so I have... Can I not? Yeah, I can extend that. I just want to be able to control this bar on the bottom to look to the side, because these are all the fields here. So we've got... let's expand these. So this is something that you may remember from previous tutorials, is that we can resize columns based on how much data there is. We've got average temperature. So that's the average temperature throughout the day. The low temperature throughout the day. The high temperature throughout the day. We've got humidity, average and low. Humidity, average, low, and high. Pressure, average, low, and high. Wind speed. So this is sort of like average wind speed throughout the day, and then what like the strongest gusts were. Wind direction is in degrees. I think degrees from the north. So this would be 292 degrees from north, which would be like southish, southwest maybe. This is how much precipitation happened in that interval. It will measure precipitation as snow. It would have been January. Some of these fields are empty. And that I've left those in just as a way of showing how data that you gather in the wild can be messy. You know, you have a device that's going to log a bunch of data, and sometimes that data doesn't exist, and those are going to be blank. So one way you can deal with this is just to delete those fields. So I'm going to do that. I'm going to click on this. I'm just going to make sure they're completely empty. Yeah, there's no data in there. So I'm going to click on O and P and delete those columns. I think UV index also has nothing in it. Yep. So we'll delete that column. And then we're going to scroll over to the right a little bit, and we're going to just get rid of all these ones here. Station voltage 2. Yeah, we're going to get rid of that. Delete. And then this. Delete those ones. Okay, so we had interval precipitation, and then inside temperature average. So that's the temperature inside the building. We have a sensor in the building. Average, low, and high. Should hover. I mean, again, these temperatures are in Celsius, so this is, you need to understand that. Oh, actually, these are not in Celsius. This is Fahrenheit. Why would it be so cold inside the building? It's weird. 50 degrees would be really hot. I don't know where this temperature sensor is. Oh, maybe it's inside the housing. It's inside the housing of the thing, and this is the temperature outside of the housing. It's not the temperature inside the building, it's the temperature inside the housing for the weather sensor, because it's inside of a weatherproof housing. Heat index, so that's a calculated field. It's based on the temperature, the humidity, stuff like that. Tell you what the heat index would be. So in the summertime, the temperature might be 80 degrees, but it feels like it's 92 or something. Wind chill, dew point, which would be, is also calculated based on the temperatures when dew would start to form. The voltage is kind of interesting. This is a measure of how full the batteries are, because this thing's powered with a solar panel that charges in the day. So actually, if you take a day's worth of voltage data from it, you'll see it kind of go up and then like hit its peak around mid-afternoon and then start going down when the sun goes down. I'm not entirely certain what wet bulb refers to. It might be soil moisture, although it looks like it's temperature related, so I don't know. I'm not sure what it is. Hang on. Okay, wet bulb refers to like what it would feel if you were outside and you were wet. It's basically a thermometer that's covered in a damp cloth, which will tell you basically how much heat would be zapped from your body if you happen to be soaking wet when you're outside at that time. Because it cools you off. That water evaporates and it sucks heat out of you. Can actually cause you to freeze. Okay, so here's what we want to do. For this one, I'm leaving this largely open-ended. Your job is to look at this data, kind of familiarize yourself with what's there, and you're going to make a series of charts. You can use some of the data, you can use all the data, you can one thing you might want to do that could be kind of interesting is to extract a particular day out of the data and then save it, so like you could go, okay, I'll create another sheet right here, and then I'm going to take just this first day's worth of data. Whoops. First day. So here, yeah, January 1st. Copy. And then smack it down in there. And then just do like a chart based on this. And we would change the sheet name to January 1st. 1/1/1/2019. Which I believe is what it is. Yeah. So you could do something like that and then just play around with it. You could play around with just like a month's worth of data. Go away. There we go. Just want to make the ants go away. So find interesting stories to tell with data, because the whole point of data is to tell stories. That's how we think. That's how humans relate to the world. We want to see what like what happened? Like what can I get out of this? Looking at these numbers tells us nothing. Humans do not interact with numbers on any sort of like really fundamental level. We need stories. And so the thing that we are good at is telling stories based on data. So a simple story you could do, grab the timestamps, grab the average temperature, go to insert, and give us a line graph. Line, 2D line. Just plop that down in there. Average temperature throughout the year 2019 through February 2020. Just before the pandemic started. Just as the pandemic was starting. It's not starting in here somewhere. So you can see cold in the wintertime, warm in the summertime, cold again in the wintertime. That's a pretty simple story that you can tell. You could do something like just the average temperature throughout a particular day. Here's January 1st, 2019. What was the temperature? What was the weather like in January of 2019? Now, you may end up with something that looks like this. This is because it's not interpreting these as time. So what we have to do is go in here and so what it's going to do is here, even here, if I did this this one right here with this line graph here, it's actually taking these, each of these days or so, there's like 365 lines on here. It's not interpreting these as timestamps, it's interpreting them as a date only. So all these are on the same date, and so it's smushing them all together, and that's what happened here. The way we can fix this is by going to the home screen, selecting this data, and then making sure that it interprets that as time. And then you get a nice little story about the day. This is when it was coldest, right away in the morning, got cold right in the morning, and then it got warmer. Same thing here. If I change this to a time, I'm actually curious, what happens if I do this as time? Yeah, not much changes, which is fine. That's probably to be expected. And I wish there was a way to tell it that it is, in fact, date and time. More number formats. Let's go time. Let's go date and time. There we go. Yeah, there we go. Now I got some more interesting data. Now you can kind of see how it's changed. And you can also see how the thing interprets time. So this is sort of like the machine also interpreting time in a certain way. The sensor box. So there you go. You can do temperature. You can do time. We could do, like, here's another thing we could play around with. Selecting time, and then remember, hold the control key to select two columns that aren't next to each other. So let's see what the voltage looks like throughout the day. Not a spark line. There we go. 2-day line. So you can see how, like, throughout the night it would get lower and lower and lower until the voltage gets kind of down here, and then the sun comes up. Okay, so it looks like around 10 o'clock it starts charging. It hits like maximum charge by like 2 p.m. and then slowly starts to go down as the sun kind of moves out of range of the solar panel. And that's going to be like a daily story. Like if you did that over a week, let's in fact try that. Let's grab everything for, say, a week. There, week. That's not quite a week. There we go. Copy. New. Week 1. Paste. Let's take the time. Let's format it as time. And let's take that column and then station voltage. Let's just see. I just kind of want to see what this looks like. Line. Yeah, and you can see over the course of a week, you can see the voltage going up and down. Must have been cloudy this day. You know, you can draw all sorts of interesting conclusions based on what data is here. Like if it's cloudy, it's not going to charge to its full voltage. It's not going to get up to that high voltage. And even sometimes here it didn't. So again, this is something you could do throughout the year. You could get an idea of what the voltage looked like throughout the year. So what do we do with these charts? Here's what I would like you to do. I want you to build 5 charts. Each one should be appropriately labeled, styled, captioned, whatever. I need you to know exactly what each chart is. So let's say I want to do that average temperature. Well, let's say I'm going to do all average temperature, low, medium, and high. Low, average, and high. Insert. Let's make it a line graph. It's going to give us our 3 lines, kind of overlapping each other. You know what, I'm just going to do average temperature because I'm going to do something simple. You guys are free to do this as creatively as you like. Then what I'm going to have you do is take this one, move it to its own sheet. We'll call it average temperature 2019. And then you can do things like play around with the styling, you know, make it look interesting. You can add elements. Depending on what kind of data you're using, you may want to add data labels. You might want to add callouts. If it's like a pie chart, you may want to add a legend, which will have, you know, I mean, when you have one color like this, the legend's kind of pointless, but if you had more than one color, then maybe it wouldn't be. You could also, if you want to, add a little text box that explains what all is in your chart. So here is a narrative about this data story. And let's call them that. Let's call them data stories. Because that's what data is for creating narratives and stories that we can relate to and use to inform the way we interact with the world. Yeah, they can be related to each other. They can be independent from each other. The only real requirement is you make 5 of them, and that you yourself can explain what each chart tells the viewer. This is real data, so there is real information and real knowledge to be found here. You just have to look around with it, play with it, spend a little time on it. Like, spend an hour playing with the data, find interesting charts, find things that look pretty. And you don't necessarily have to do line graphs. You can also do things like, what does it look like when I compare average temperature with average humidity in, say, a scatter plot? What is that going to look like? What does this tell us? Temperature versus humidity. Let's swap the rows and columns. No. Oh, okay, whatever. Wouldn't let me do that. But yeah, this tells us something interesting too. Maybe, I don't know, you can correlate anything with anything else and you can get really interesting results. So play with it, see what you find out, and we'll see you in class.